In this video, we'll look at how quadratic functions are defined and what their graphs look like. So let's start with the definition. A quadratic function is defined to be a function that can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are constants, and we're talking in terms of real numbers there for constants, and specifically a is not equal to 0. Now, that's an important distinction. It doesn't say that b and c can't be 0. So what that's really saying is you have to have that x squared term. To be a quadratic function, you must have an x squared term. And it can't be any higher than that. Notice our other terms are a constant term c and then an x term. There's no other higher degrees. So you must have an x squared and nothing higher for a function to be a quadratic. So let's look. I've got 6 functions listed below. Let's look at which ones are quadratic. So our first function f has an x squared term, and it doesn't have any other higher degree term. It has an x term and a constant term, so that is a quadratic function. I'll just put a Q there for quadratic. G of x also has an x squared term and an x term, but it's got that x squared term, so that's a quadratic. Notice g of x doesn't have a constant term. That's okay. There's no constant added on. In essence, that constant would have to then be 0. So therefore, it's okay, because remember, a, b, and c are constants. The only one that can't be 0 is a, so it's okay for c to be equal to 0. In h, the function h here, we have an x squared term, and that's it. We don't see any other x terms. That is the result of having a 0b and a 0c. So again, in terms of our constants, a is the only one that can't be 0. It's okay for the other 2 terms to basically disappear. So this is as well a quadratic. K has the x term missing, but it has the x squared term. So again, that's a quadratic. When we look at P, notice there's no x squared term. In fact, it just has an x term and a constant, so it's actually a line. It is not a quadratic function, so that's not quadratic. And our last example, W, does have an x squared, but notice it has a higher degree term as well. We cannot have anything higher than an x squared term. You can only have an x squared term, an x term, and a constant term, potentially in a quadratic function, and this has something higher, so that would not be a quadratic. So the first 4 functions were quadratic, but not the last 2. All right, so let's use Desmos to just investigate what those quadratic function graphs look like. So we'll start with f of x and just type it in. You'll notice as I type in, we have the graph that automatically comes up. Here I have the full graph or equation typed in, and what we see is a bowl-shaped curve. Okay, so this is very different from a line. Let's type the other one in and see how that looks. G of x equals -1/2 x squared plus 3x. All right, we still have this curve shape. It's almost like a bowl upside down. So there's kind of a theme happening here. Let's try h of x equals -6x squared. Once again, we're looking at the orange graph, and we're still seeing a bowl. Again, just like the last one, it's upside down, but we do definitely have a bowl shape. And then my last equation or function was k of x equals 3x squared minus 7. All right, very similar to the original graph I had. It's a little lower and a little shifted, but it's opening up just like we see with that first blue graph. This purple graph is going up just like a bowl that continues to open up and out as it goes. So we see a theme here that quadratic functions, that x squared is creating a bowl shape in the graph. We're going to look at some details and some vocabulary related to that graph. So using Desmos, we saw that our quadratic functions ended up in a bowl-shaped graph. That bowl-shaped graph is what we call a parabola. A parabola is either going to open up or down from a single point, and as you move away from that point to the right or the left, the graph is going to get steeper. I've got two examples down below. Now that single point the parabola opens up or down from is what we call the vertex. Okay, so the vertex in this first graph was down here at -1, -7. In the second graph, it was up here at 3, 4.5. Now, when we think about that, because it's a bowl, either opening up or down, that point, that vertex where it's opening up or down from, is actually going to either be the lowest point on the graph. So sometimes we refer to that as the minimum, specifically y value, or if the parabola is opening down, this would be the highest point, or the maximum y value. So the vertex is really an important point on the graph. Not only is it where the parabola opens up or down from, but it's also kind of the lowest or minimum value or the highest or maximum value, depending on whether the bowl is opening up or down. The other thing about these parabolas is that they all have symmetry. When you examine them, looking to the left and the right of where you see that vertex, what you're going to see is that the graph looks exactly the same in terms of being a mirror image on the two sides. So if I were to look through, I'm going to use a dashed line here, this first parabola, what you see is the left side is a mirror image of the right side when you think about the vertical line through the vertex as being a kind of a mirror. We call that vertical line the axis of symmetry. So in this graph, the axis of symmetry, I'm going to abbreviate here, would be the vertical line going through this point of -1, -7. Remember, all vertical lines are going to be given as x equals the x value associated with it. So the x value here is -1, so the axis of symmetry is x equals -1. In my second graph, my vertex has an x value of 3, so I have a mirror image on either side of x equals 3. So the axis of symmetry would be at x equals 3. Okay, so this graph is going to be very consistent as we look at quadratic functions, a parabola. We're going to use Desmos to investigate a key part of the equation of a quadratic function, and that is the x squared term. That's what you need for it to be a quadratic equation, and in particular, the a in front of the x squared, the coefficient, how does it impact the graph? So to do that, we're going to look at f of x equals x squared, ax squared. And notice when I put an a in, Desmos says add a slider. And I'm going to click on the a to create a slider. What a slider does in Desmos is it allows me to change the value of that constant, or in this case, coefficient of a. So right now, notice it says a equals 1. That means my graph here is using 1 for a. All right, so right now I have f of x equals 1x squared, or just simply x squared. Now, what I can do with the slider is I can change the value of a. So I can make it bigger, and notice the parabola gets skinnier as it gets bigger, or I can make it go down, and it got fatter as I got closer to 0. Now when I get actually to 0, the graph in essence goes away. It becomes a line, and that's not a quadratic equation. So remember how we said a cannot be equal to 0. Well, in Desmos slider it doesn't know that, but we'll continue on and make it negative though, and notice the parabola comes back up. We get the bowl shape, but now the bowl is opening down as I go into a negative value of a. And as I make that a bigger value, it gets skinnier and skinnier. So what we see is that a does two things. It influences how skinny or fat the parabola is and whether the parabola opens up or down. So if a is positive, the parabola is opening up. If a is negative, the parabola is opening down. And then it turns out our standard shape for a parabola would be at a equals 1. So this is the standard shape. What we say is that if a is greater than 1, it's a skinnier or narrower parabola, and that includes ignoring the signs. If we think about a, the absolute value of a, as being greater than 1, so it would be a -2. It's a skinnier parabola, but opening down. But if we're between 1 and 0, then we've got a fatter parabola, and that includes for negative values as well. Using Desmos, we saw that the coefficient a of the x squared term determines whether the graph moves up or down and how quickly it increases in height. In other words, how narrow or wide the parabola is. In particular, we saw that when a is positive, greater than 0, then the parabola opens up. When a is negative, the parabola is opening down. So that's a real simple rule, pretty easy to remember. Positive up, negative down. When the absolute value of a is greater than 1, so a is 1, 2, 3, 4, 5, etc., or -2, -3, -4, -5. So when it's greater than, the absolute value is greater than 1, then what you're going to have is a graph that appears narrower because it's being stretched more by the high value of a. When a, the absolute value of a, is less than 1, so when you have a decimal value less than 1, the parabola is going to move up more slowly or down more slowly, and so the graph is going to appear to be wider. So here's 3 functions. They're all quadratic, and let's use them, the equations, to determine whether the parabola is opening up or down, and whether it's going to be a standard, narrower, or wider width. So first function, f of x equals -x squared plus 2x plus 6. We want to determine these things, we want to look at the x squared term. So we have a -x squared. That implies that a is -1. Because a is negative, that means the parabola opens down. And then because it's a 1 is going to be that standard width. It's going to be not too skinny, not too fat. So it's a standard width. All right, our next function g, once again, look for the x squared term. That's going to influence what's happening in terms of up, down, and the width of the parabola. So we've got an x squared term here, 0.2x squared. Since a is 0.2, that's positive. The parabola is going to open up. And it's going to be a wider parabola because this is a value positive, but it's less than 1. So that means it's going to increase more slowly, so it's going to be a wider parabola than standard. And our last function, h of x, once again, look for the x squared term, and it actually comes up second here. Even though we typically, when we're writing out the definition, put the x squared first, when you look at specific functions, it doesn't have to be the first term. So here it comes last, and our a value is -2. That's a negative value, so the parabola is opening down. And because it is a value that is greater, the absolute value is greater than 1, it would be a narrower parabola. So a influences both whether the parabola opens up or down and how wide the parabola is.